Right, lesson 5, module 6, video 2, and now we're going to look at our green points that we have here, right? We have 0, 7, 2, 7, 4, 7, and 10, 7, and as you can see, they are also collinear, right? They're also making a line, and we're going to call that line W. All right, same thing with our other line. We could name it by some points on the line, like how we could have A, B, like this, or we could use fancy script writing and call it line W. What do we notice about line W? They all have the same Y coordinate, which is 7, but they have different X coordinates along the way, right? Very good. And to find the distance between two horizontal lines, find the vertical distance between one line and any point on the other line. So line W and the x-axis are both horizontal lines. Line W and the x-axis, both horizontal lines. So to find the distance between line W and the x-axis, then we would just need to see how many units we have here, which would be 7 between any point, right? Okay. What lines are line W parallel to? Parallel, going on forever and never touching. Here's your line W. It is parallel to your x-axis as well as any horizontal line, right? Any horizontal line. Is line W perpendicular to the y-axis? Line W perpendicular to the y-axis? Yes, because it forms a right angle with the y-axis. We could put a little box there showing that it's forming a right angle. It is perpendicular. Okay, very good. Let's go on and look at these points. Okay, here I have 3 points, point A, point B, and point C. What do you notice about these points? Look at the ordered pairs to help you. Do you notice that they have the same y coordinate? So if they have the same y coordinate, just by looking at the ordered pairs, you know that they're going to be 2.5 up the y-axis, and they're going to form a horizontal line going across from the y-axis, 2.5 units up. So they're going to be on a horizontal line, and they're all going to be the same distance from the x-axis. They're going to be 2.5 units from the x-axis. Okay, so that's just so you know that you can look at descriptions of points without actually having the points, right? Okay, now we're going to go in your Learn book to the magnifying glass page, and it's going to look a little bit like this. And you can see we have a line L here, right? Is the point 5, 6 on line L? And how do you know? Okay, point 5, 6. 5 across and 6 up. So 0.56 is here. Is that on line L? No, because line L is all 5. This is x 5, y 6. All of line L is going to have a y of 5, right? Okay, y coordinate is going to be 5. Identify the ordered pair for a point that is on line L but is not visible on the part of the coordinate plane that we see. Okay, so since our lines go on forever, you see the arrows on both sides. What is a point that's on that coordinate plane that's not less than 10? What about 12, 5? Right? Because it would be an x of 12 and a y of 5. So we always have to have the y of 5. What about 105? Right? Because the line goes on forever. Even 17.5, 5. Would that work? Right? Even fractional numbers, 17 1/4. 3 and a fifth, because they're not grid lines on here. Well, 17 and a half because it's more than 10. I guess anything that's inside of here would count even if it doesn't have a grid line. Sorry for that mistake. But anything more than 10 is what we're looking for that's not visible there. Okay? What is the distance from line L and the x-axis? 5, right? And what is the line L parallel to? The x-axis and every other horizontal line, right? Okay. So now that we have some good understanding, let's look at exactly what it says there. It says, draw a line on the coordinate plane that is parallel to the x-axis but a greater distance from the x-axis than line L. Okay, so they just mean it has to be larger than line L, higher up on the y-axis. So you could draw your line M anywhere. I'm going to draw mine at 9. Arrows on both sides, and I'm going to call it line M with a fancy M there. And write the ordered pairs for 3 points on line M. Okay? Can you challenge yourself to write an ordered pair or 3 of them for any point on line M? I know that my y is always going to be 9. So I could have 1, 9. I could have 2, 9. I could have 3, 9. 4, 9, 5, 9, 6, 9, 7, 9, right? Anything on line 9. Yes? Okay. And if you put yours on somewhere else, if you put it on 7, then it's going to have your y-axis of 7, your y-coordinate of 7. All right. The next thing it says is draw a line on the coordinate plane that is parallel to the x-axis, but a shorter distance from the x-axis than line L, and label it line N. Okay, so anything shorter, I'm going to pick 2. You pick what you want. And this is N, so I'm going to just put a fancy N there. I'm sorry my line isn't exactly on the line. I am human. And ordered pair for 3 points on line N. So we know that our y has to be 2. So I'm just going to say 1, 2, 2, 2, 3, 2. And I could double check. 3, 2 is right there. It's always good to double check, right? You could get confused. How do the y-coordinates on the points on line M compare to the y-coordinates of the points on line N? They are greater, right? The y-coordinates are higher. My line M has 9s and my line N has 2s. So they're farther above. They are greater. What do lines L, M, and N have in common? They are all horizontal, right? They are all, could draw my little sunshine on there, horizontal like the horizon. They are parallel to one another and they are parallel to the x-axis. Okay, let's go to number 2. If you need to pause me, you can pause me or screenshot me and get that taken care of. Okay, the graph shows line F. Plot a point that would lie in the same vertical line as point F and name the new point E and record its ordered pair on the coordinate plane. Okay, so I can put it anywhere as long as it's going to be collinear with F. Vertical line has to be vertical. Okay, so it can just be anything that also is a 4. I'm going to put it up here at 16. I'm going to call it E, and I have to write it. So I'm going to say that it is 4. That's my X, and my Y is 16. Okay, and then it says draw line EF, because now I have 2 points, right? So now we can call it line EF. There's 2 ways to name lines, right? This is one way to name the line, by the points on the line, and I'm going to draw that line just like that, line EF. Okay, and that was number 2. What do you notice about the ordered pairs for all possible locations of point E? They're going to have the same x-coordinate of 4. Yes. Why do the ordered pairs for possible locations have the same x-coordinate? because they're all on this line, right? Are points E and F collinear? Collinear, sharing that line. Are all points EF the same distance from each other? No. They could be anywhere on this line, right? Are they all the same distance from the y-axis? Yes, they are. They're all going to be 4 across. Which axis is EF perpendicular to? The x-axis, because it's going to form a 90-degree angle. Okay? Oh, we learned a lot today. Awesome. Thanks for your hard work. Aloha.